Hi dear students, this is me Ishfaq Riaz and today we'll be discussing another important and interesting topic of physics, that is acceleration due to gravity. 9th class का topic है chapter gravitation का. So before this very topic we have already discussed the concept of universal law of gravitation, then the expression for F, that is equal to G m1 m2 divided by r square, और उसके बाद हमने डिस्कस किया कैरेक्टरिस्टिक्स ऑफ ग्रेविटेशनल फोर्स. और इस वक्त जो हम पढ़ने जा रहे हैं वो है एक्सेलरेशन ड्यू टू ग्रेविटी. In this very topic we will discuss the definition of acceleration due to gravity and we will try to derive the expression for acceleration due to gravity, and in the end we will discuss the factors upon which this acceleration due to gravity depends. लेकिन students, my dear students, acceleration due to gravity से पहले मैं आपको कुछ definitions बताने जा रहा हूँ. Like what is meant by a freely falling body? What is a freely falling body, or what do we mean by free fall? So if I consider a body that is like this, if I have a ball here, if I throw it upwards or downwards, or if I release it from rest under the effect of gravity alone, this body is called a freely falling body, because the only force which is acting on this very body is the gravitational force. So this is called a freely falling body, simply a body thrown upwards or downwards or simply released from the rest. That is called a freely falling body, and this phenomenon is in physics, it is called free fall. So you understood the concept of freely falling body and free fall. Now let us look at this very ball once again. If I throw it upwards, it will reach to certain height and then it will fall down. If I give it a little bit greater velocity, it will reach to a greater height, and at that very point, I mean at the highest point, its velocity will become zero and then it will again fall down. So this body, its velocity changes during this free fall, and whenever the velocity of a body changes, आपको याद है definition of acceleration की, rate of change of velocity, that is change in velocity divided by time taken, right? This is the definition of the acceleration. Now the velocity of this freely falling body, it is changing, and we say that this body is accelerating. Since it is accelerating under the effect of gravity alone, the acceleration produced in this very freely falling body, that is called the acceleration due to gravity. So what do you mean by acceleration due to gravity? Simply, it is the acceleration produced in a freely falling body under the effect of gravity alone, right? Now हम इसको फिजिक्स में कैसे डिनोट करते हैं? स्मॉल जी से हम इस एक्सेलरेशन ड्यू टू ग्रेविटी को डिनोट करते हैं, और इसका वैल्यू मैं आपको बताऊंगा. ऑन और नियर द सरफेस ऑफ अर्थ इट्स वैल्यू इज 9.8 and the SI unit of this small g is same as that of acceleration, that is meter per second square. This is acceleration due to gravity and its value in SI system on or near the surface of earth. ठीक है ना? और ये जो acceleration due to gravity है, it is a vector quantity. What do you mean by vector quantity? It possesses both magnitude. क्या होता है इसका magnitude? 9.8 meter per second square on the, or near the surface of earth. और इसकी direction है, it is always directed vertically downwards towards the center of the earth. So this g, it is basically a vector quantity, so it possesses both magnitude as well as direction, and the direction of this acceleration due to gravity is always vertically downwards towards the center of the earth, right? So this was about the definition of acceleration due to gravity, right? Now let us try to derive the expression for small g. So let me write here expression for acceleration due to gravity. I mean on what factors it depends. So this is expression for small g, that is acceleration due to gravity. Let us try to verify the factors upon which this small g depends. Okay, इसके लिए मैं क्या consider करूंगा? Let me consider earth to be a perfect sphere, but actually Earth is not a perfect sphere. Let us assume it here. Let me assume Earth to be a perfect sphere of mass m, and remember one thing, this mass, it is assumed to be concentrated at its center, I mean center of mass of the Earth. This Earth, it is considered to be a perfect sphere of mass m, which is supposed to be concentrated at its center. And let me suppose, मैं suppose करूँगा इस अर्थ की रेडियस जो है वो कैपिटल आर है, राइट. नाउ इफ आई कंसिडर ए बॉडी ऑफ मास स्मॉल एम, मैं एक बॉडी लूंगा, इसका मास स्मॉल है, स्मॉल एम है, दैट इज ऑन द सरफेस ऑफ अर्थ. लेट अस ट्राई टू फाइंड आउट द एक्सप्रेशन फॉर एक्सेलरेशन ड्यू टू ग्रेविटी on or near the surface of earth. ठीक है ना. So when the body of mass small m is on the surface of earth, then the distance between the two, I mean this capital M and small m, it becomes r. You are getting my point or not? Now I can use the universal law of gravitation. याद है ना उसका स्टेटमेंट मैंने पहले ही लेक्चर में आपको बोला था, F is equal to G, हाँ, m1 m2 divided by r square. Let us apply the same law here, and I will get the force of attraction between the earth and a body of mass m on or near the surface of earth. It will be given by G. So mass of earth I will represent it by capital M, and mass of body by small m, and the distance between their centers is r. So let me write it r square. ठीक है ना. Now the force with which a body is attracted towards the center of the earth, that is basically called the weight of the body. आपको न्यूटन सेकंड लॉ याद होगा. As per the statement of second law, F is equal to ma. We derive the expression F is equal to ma from the statement of Newton second law of motion. लेकिन ये जो acceleration here, लेकिन ये जो acceleration है, यहाँ पे मैं इस a को replace करूंगा g से, small g से, because this is acceleration due to gravity here. So the force with which a body of mass small m, it is attracted towards the center of earth, that is called weight of the body. Or as per Newton's second law, this F is equal to ma, but here I will write F is equal to mg, where g is the acceleration due to gravity, जिसके हमें यहाँ पे expression निकालनी है. ठीक है ना. This on the LHS of these two equations, you can see the same force. I used the here universal law of gravitation, here Newton's second law. Since F is same, so from first and second I will get this mg, I mean RHS, this is equal to g capital M small m divided by r square. ठीक है ना. तो m और m यहाँ cancel हो जाएगा. So g is equal to g m divided by r square. This is the expression for acceleration due to gravity, right? So this is equal to gm divided by r square. You are following the steps or not? Simple hai. You have to combine first and second. Simply you will get small g is equal to gm divided by r square. Now let's write few points regarding this very expression. That is, let me write here few notes regarding this expression. Now you can easily see from the expression of g, it is equal to g, that is universal gravitational constant, mass of earth, and square of the distance between small m and capital M, right? Does it depend upon the small m, I mean mass of the body itself? You cannot see small m from this very expression. So I can say ये जो capital G है, it does not depend upon the mass of the body itself. What does this mean? What does this mean? All bodies, whether small or big, hollow or solid bodies, they will fall at the same rate, they will have the same acceleration due to gravity, because ये जो small g है, it does not depend upon the mass of the body itself, right? Now can I interpret from this very result, क्योंकि आपको equations of motion में आपने सीखा होगा, S is equal to ut plus 1 by 2 at square. In free fall, I mean for freely falling bodies, I will replace S by h, that is the vertical height, that is equal to ut plus 1 by 2. Here I will replace a by g, this is equal to gt square. Now if a body is simply dropped from rest, that is if the initial velocity of the body is equal to 0, you can simply see h is equal to 1 by 2 gt square, right? Now, now, if two bodies of different masses, if they are allowed, I mean if a light body and a heavy body, if they are allowed to drop, if they are allowed to fall from the same height, they will hit, because G is same. It does not depend upon the mass of the body whether it is light or heavy, right? So they will hit the earth simultaneously. You are getting my point or not? If the two bodies, whether a light body, a paper, and a heavy body, a ball, if they are allowed to fall from the same height, because of the same value of the G, T will remain same. So they will hit the earth simultaneously. But you are not able to see it for a paper, because if this is a paper that is crumpled into a ball, and if I drop a sheet of paper, and if I drop a sheet of paper from the same height, you can see this sheet of paper, it will fall slower. क्यों होता है ये real life में? Because of air resistance. जी हाँ dear students, you have to remember it. This is because of air resistance. If you drop these two bodies, a light body and a heavier body, a paper crumpled into a ball and a sheet of paper, if you allow to fall them from the same height in a vacuum, they will hit the earth simultaneously, right? यही एक ये बिलीव किया जा रहा है, एक स्टोरी है बेसिकली, बिलीव किया जा रहा है. ये जो गैलीलियो है, एक फिजिस्ट है बेसिकली, he used to drop different objects from Leaning Tower of Pisa in Italy to prove the same result. That is, a light body and a heavier body, if allowed to drop from the same height, they will hit the earth simultaneously. They will hit the ground at the same time. क्यों? Because ये जो small g है, it does not depend upon the mass of the body, right? Now let us write down the note second regarding this small g. So let me rub this. Number 2, from the expression you can see G, universal gravitational constant, same throughout the universe. Mass of earth, it is also constant. The distance between that very body which I considered in the diagram, I mean the radius of the earth, it is constant. So G, since capital G is constant, mass of earth is constant, radius of earth is constant if I consider earth to be a perfect sphere, right? So G on or near the surface, it is constant, right? Now अब मैं इसका वैल्यू अगर निकालना चाहूं तो इसमें मैं G, M और R के values you already know. If I substitute those values here, I will get the expression for acceleration due to gravity on or near the surface of earth. So I will write G is equal to, अब बताओ, अब आपने ये वैल्यू याद रखा कैपिटल G का? हाँ, this is 6.67 into 10 raised power minus 11, right? What about the mass of earth? You have to remember these, 6 into 10 raised power 24 kg, ठीक है ना? And the radius of earth, that is equal to 6.4 into 10 raised power 6. इसका मैं अगर स्क्वायर लूंगा, you will have to calculate this value, you will have to calculate this very value, and you will simply get G is close to 9.8 meter per second square, which is the presently accepted value of G on or near the surface of earth. So it is constant on or near the surface of earth, right? So this is the value of G on or near the surface of earth. One more point which I would like to discuss about the small g, that is acceleration due to gravity, is that since G is constant, it is same throughout the universe. Here M is mass of earth because we are on the surface of earth, and I have considered earth to be one body, or is radius of earth. So from this very expression you can easily see small g depends upon the mass of planet, because mass of planet is different for different planets, and it also depends upon the radius of the planet, because radius of planet is also different for different planets. So simply I can write ये जो small g है, it is different for different bodies, or I can say it is different for different planets. So I will write one more expression for small g like this. ये जो small g है, I will write it G because it is universal constant. M के बदले लिखूंगा mass of planet, here I will write G on any planet, और नीचे denominator में लिखूंगा radius square, I will write radius of planet square. So simply I can write ये जो acceleration due to gravity है, it is different on different planets because of this very expression. So it depends upon the mass of planet and the radius of the planet. Now let's try to calculate the value of acceleration due to gravity on the surface of moon. Moon is not a planet, but it is basically a natural satellite of earth. It revolves around the earth. Now let us try to calculate g on the surface of moon. From this very expression I will write g, it is universal constant, m I will write mm, that is mass of moon divided by radius square, radius of moon square. G का वैल्यू तो आपको पता ही है, that is 6.67 into 10 raised power minus 11 units you know. Now what about the mass of moon? याद होगा आपको 7.4 into 10 raised power 22 kg divided by what about the radius of moon? It is 1.74 into 10 raised power 6 denominator square. Now इस एक्सप्रेशन को simplify करने के बाद, simply this involves mathematical calculation, you can simply use bases are same, powers are added. You can take the powers separate, 10 raised power minus 11, 10 raised power 22, in the denominator you have 10 raised power 12, जब ये ऊपर आएगा this is 10 raised power minus 12. If you simplify this, you will exactly get this is 1.63 meter per second square. This is the acceleration due to gravity on the surface of moon. Is it less or more? You can easily see it is less as compared to the acceleration due to gravity on the surface of earth, right? So can I write acceleration due to gravity on the surface of moon? Can I write it in terms of acceleration due to gravity on the surface of earth? I mean, can I write it like this 9.8 by 6? क्यों? ये जो 9.8 है, it is acceleration due to gravity on the surface of earth, ठीक है ना? If you divide 9.8 by 6, you will exactly get 1.63. So I can write g on the surface of moon. What is 9.8? It is g on the surface of earth divided by 6. तो हमने एक expression derive की, relation एक derive की, acceleration due to gravity on the surface of moon and acceleration due to gravity on the surface of earth. So g on the surface of moon, it is equal to 1 by 6 times g on the surface of earth, or you can write gm divided by ge, I mean acceleration due to gravity on the surface of moon divided by acceleration due to gravity on the surface of earth, and the ratio is 1 by 6. If you use the concept of weight, अगर आपको याद होगा expression weight की, the force with which the body is attracted towards the center of earth, as per physics, weight is not mass, it is basically the force. So F, that is equal to force, that is equal to weight, that is equal to mg. Now what is the ratio between the two? If this is weight on the surface of moon, this is weight on the surface of earth, because हमने अब ये relation derive ही की. Now let us try to find the relation between the corresponding weights. So weight on the surface of moon, it will be mass, mass is constant throughout, so this is m into gm divided by m into ge. Since mass is constant, mass m और m cancel हो जाएगा. अभी मैंने relation derive की, gm by ge, it is equal to 1 by 6. That is weight on the surface of moon divided by weight on the surface of earth. The ratio is 1 by 6, or you can simply see weight on the surface of moon is 1 by 6 times the weight on the surface of earth. This was all about acceleration due to gravity, expression for acceleration due to gravity, and the special points regarding the acceleration due to gravity, right? Now let's try to write some factors upon which this small g depends. I mean acceleration due to gravity. So let me write here variation in the value of g. So let me write variation in the value of g. क्या ये small g constant रहता है at every place? अभी आपने देखा it depends upon mass of planet and radius of planet, and on the surface of earth it changes from place to place as well. और आपको 4 factors याद रखने हैं जिन पे ये small g, I mean acceleration due to gravity, it depends. वो 4 factors क्या है? Number 1, it depends upon the height. I mean if we go above the surface of earth, what will happen to acceleration due to gravity? Basically 11th class में आपको ये पढ़ना है. मैं आपको पॉइंट बताऊंगा, एक्सप्रेशन तो मैं यहाँ डिराइव नहीं कर सकता हूँ, लेकिन वो रिजल्ट जरूर बताऊंगा आपको. It depends upon the height, or you can say it depends upon the altitude or altitude, right? So it depends upon height or altitude. कैसे डिपेंड करते हैं मैंने पहले ही कहा, आपको बस एक्सप्रेशन बताऊंगा. G prime is equal to, I mean G prime, it is acceleration due to gravity at some great height. g prime is equal to g into 1 minus 2h by r, और ये जो एक्सप्रेशन है it is only valid when the height is very much less than as compared to the radius of the earth, ठीक है ना। और ये बात मैं आपको जरूर बताना चाहूंगा, with height or altitude this acceleration due to gravity it decreases with height, right। नंबर 2 जो फैक्टर है जिस पे acceleration due to gravity डिपेंड करती है वो है depth below the surface of earth, so it changes with the depth, that is small d, that is depth below the surface of earth, and let me write the expression g prime is equal to g into 1 minus d by r। और एक और बात, g prime acceleration due to gravity at some depth, g acceleration due to gravity on or near the surface of earth, so it is less than g prime is less than g, you can clearly see it, so acceleration due to gravity with depth also decreases, ठीक है ना। और इंटरेस्टिंग पॉइंट मैं आपको यहाँ पे बताने जा रहा हूँ, एट द सेंटर ऑफ अर्थ, लुक एट दिस वेरी फिगर, इफ वी गो डीप इनटू द सरफेस ऑफ अर्थ, आई मीन इफ वी गो टुवर्ड्स द सेंटर ऑफ अर्थ, व्हाट विल हैपन टू डी एट द सेंटर ऑफ अर्थ, इफ आई ट्राई टू फाइंड द एक्सेलरेशन ड्यू टू ग्रेविटी एट द सेंटर ऑफ अर्थ, हाँ एट द सेंटर ऑफ अर्थ ये डेप्थ क्या होगी, it will be equal to the radius of the earth, you are getting my point or not, deep below the surface of earth, at the center of earth, I mean oh this depth it will be equal to radius of the earth। आपको बात समझ आ रही है ना, when we go deep into the surface of earth and reach the center of earth, at this very point this depth is basically equal to the radius of the earth, so I can write it here, so g prime is equal to g into 1 minus d के बदले क्या लिखूंगा r divided by r, r और r कैंसल हो जाएगा, यहाँ पे 1 रहता है, so 1 minus 1 is equal to 0, 0 into something is 0, so g prime is equal to 0। and interesting fact आपने याद रखा, अब acceleration due to gravity decreases with depth, and when we reach the center of the earth the acceleration due to gravity becomes 0। What will be the weight at this very point? Obviously 0. So this is variation of g with height and depth. Now the third factor upon which the acceleration due to gravity depends is shape of the earth। लेक्चर से पहले ही मैंने इस लेक्चर के शुरुआत में ही मैंने आपको बताया था, ये जो अर्थ है it is assumed to be a perfect sphere of mass m and radius r, लेकिन रियल लाइफ में अर्थ इज नॉट ए परफेक्ट स्फीयर, इट इज बल्ज्ड एट द इक्वेटर, it is bulged at the equator and it is flattened at the poles। This is east, west, north, south, so these are the poles and this is equator। क्योंकि real life में earth is not a perfect sphere but it is like an ellipse, this is what is called ellipse from mathematics point of view। So this is equator and these are the poles, and because of this the radius of earth it is different, I mean this equatorial radius it is different from the polar radius। और एक्सप्रेशन आपको याद ही होगी, g is equal to gm divided by r square, g is constant, mass of earth is constant, so I can write g is inversely proportional to r square। डायग्राम में आप इजीली देख सकते हो, ये जो इक्वेटोरियल रेडियस है इट इज ग्रेटर देन द पोलर रेडियस, राइट। अगर आपको ये भी याद रखना है, मैं एक पॉइंट बताऊंगा आपको, इक्वेटोरियल रेडियस माइनस पोलर रेडियस इट इज इक्वल टू 21 किलोमीटर। व्हाट आई मीन बाय सेइंग दिस इज दैट इक्वेटोरियल रेडियस it is greater than the polar radius by 21 kilometers, so RE it is greater than RP, you can easily see it from this very figure, from this ellipse, ठीक है ना। लेकिन G और R के दरमियान inverse relationship है, when R is more G is less, when R is less G is more। Look at this very figure, since RE is greater than RP, so G at equator it will be less, so I will write it here, acceleration due to gravity at the equator it will be less than acceleration due to gravity at poles। Can I say it like this, acceleration due to gravity it is maximum at poles, ये जो g है it is maximum at poles, and I will write g is minimum at equator because of the difference of equatorial and polar radii, right? So G is maximum at poles and minimum at equator. क्या मैं इसको ऐसे भी कह सकता हूं because earth it is always in the rotation, rotates about this very axis in equatorial plane, I mean from west to east in anti-clockwise direction. This is the direction of rotation of earth, ठीक है ना? So when we move from equator to poles, what will happen to acceleration due to gravity? Since r goes on decreasing and acceleration due to gravity will increase. So as we move from equator to poles, I mean as we move from equator to poles, the acceleration due to gravity will increase. So these were the three factors upon which acceleration due to gravity depends. Now the last factor upon which small g depends is that it depends upon the rotation of earth as well. अभी मैंने आपको बताया ये जो earth है it rotates about this north south, that is the axis of the earth, and it rotates in anti-clockwise direction from west to east. I mean the direction of the rotation of the earth, it is from west to east. Because of the rotation of the earth, the value of small g, I mean acceleration due to gravity changes. ठीक है ना? लेकिन expression लिखूंगा, but that is beyond your scope at this stage. You will have to study this very relation in 11th class. बस मैं relation लिखूंगा, g prime is equal to g minus r omega square cos square lambda. ये जो lambda है, this is called the latitude at a place and this omega is angular speed of rotation of the earth. यहाँ पे मुझे बस यही result निकलता है, g is maximum at poles और ये जो small g है it is okay, g is maximum at poles and g is minimum at equator. From this very relation I will again get g is maximum at poles and minimum at equator. क्या मैं आपको एक क्वेश्चन पूछूं regarding the weight of a body? आप क्वेश्चन नोट कीजिएगा and give me the answer. Where will it be profitable to purchase 1 kg sugar? Your options are equator, poles, 40 degree latitude or 45 degree latitude. Once again I will repeat the question. Where will it be profitable to purchase 1 kg sugar? Your options are equator, poles, 45 degree latitude, 40 degree latitude. You think about it and give me the answer. So these were some of the factors upon which small g depends. और अगर मैं अब ग्राफ प्लॉट करूंगा, क्योंकि अगर आप नीट का शौक रखते हो एमबीबीएस के लिए, क्वेश्चन एक आया था नीट में, मैं ग्राफ बताऊंगा आपको क्या ग्राफ है वो. बेसिकली द वेरिएशन ऑफ जी, अगर आप अर्लियर क्लासेस से ही मेहनत करना शुरू करेंगे देन इट इज नॉट impossible to do anything. You can qualify these competitive exams, right? So if I plot the variation of acceleration due to gravity with r, this small r is distance from the center of the earth. और ये जो ग्राफ है अभी मैंने आपको बताया, what is small g at the center of earth? It is 0 and the expression and the variation of g is like this. So it will be like this. G is maximum when r is equal to r, I mean the radius of earth. So at this very point g, it is equal to g, I mean the acceleration due to gravity on the surface of earth, and then it goes on decreasing as per the inverse square relationship. So this is at the center of earth, the linear graph, and then it goes on decreasing as per the inverse square relationship. So this is the variation of acceleration due to gravity with distance r, but remember here one thing, this r is from the center of the earth, right? So let us try to find out the mean density of earth using the concept of acceleration due to gravity. आपको पता ही है density as per the expression density rho, it is equal to mass per unit volume. ठीक है ना? Now since once again I will consider earth to be a perfect sphere of mass m and radius r, so I will write it mass m. Since it is considered to be a sphere, so as per the mathematical formula, volume of sphere is equal to 4 by 3 pi r cube. So density rho, ये 3 ऊपर जाएगा, this is 3m divided by 4 pi r cube. ठीक है ना? अभी मैंने expression derive की small g के लिए, that is equal to gm divided by r square. ठीक है ना? जरा m निकाल के दे दो इसमें, m is equal to gr square divided by capital G. Let me substitute it here. So ये जो डेंसिटी ऑफ अर्थ है, मीन डेंसिटी ऑफ अर्थ है, किसके बराबर निकलेगा? 3 इंटू, हाँ m के बदले क्या लिखूंगा? दिस इज जी आर स्क्वायर डिवाइडेड बाय 4 पाई आर क्यूब इंटू जी. ठीक है ना? ये आर स्क्वायर और आर स्क्वायर कैंसिल हो जाएगा, नीचे एक आर रह जाएगा. तो ये जो एक्सप्रेशन है डेंसिटी की, इट विल बी इक्वल टू 3g divided by 4 pi r capital G. Now, on the surface of Earth, you know the value of small g. You also know radius of Earth and this universal gravitational constant. By substituting the values, you will get the expression for mean density, rather the value of mean density of Earth. This is 5.5 into 10 raised to power 3 kg per meter cube. That is simply equal to 5.5 times the density of water. This is the density of Earth in terms of density of water. So we calculated the value of density of Earth from the concept of small g, that is acceleration due to gravity, right? So let me revise the things which we discussed today in this topic in a glance. I started from free fall, freely falling body, acceleration due to gravity. उसके बाद मैंने derive की expression for acceleration due to gravity, special points regarding g, और उसके बाद हमने डिस्कस किया वेरिएशन इन द वैल्यू ऑफ जी. नाउ एक और असाइनमेंट में आपको रखूंगा, यू हैव टू डिफरेंशिएट बिटवीन स्मॉल जी एंड कैपिटल जी, एंड इन द एंड वी फाउंड आउट, we calculated the value of density of Earth. This was all about regarding the acceleration due to gravity. Hope you enjoyed the lecture very well.